Hello everyone, today we are going to solve question number 53, maximum subarray. Given an integer array nums, find the subarray with the largest sum and return its sum. Okay, so in this video I'm going to discuss three methods to solve this question. First two are basically to build your intuition about what the question actually demands, and the third one which is going to be Kadane's algorithm. Okay, so let's go and see what the first method is. So currently, we are discussing brute force approach. Our main constraint is you have to return the largest sum inside the subarray. It can also be the whole array. It can also be a part of it. Okay. This method is going to have a time complexity of O of n cube, space of O of 1. Okay. So in this brute force approach, what we are going to do is first we are going to use one loop to pick the beginning of subarray, second loop to pick the end of subarray, and inside the second loop, we are going to define sum to calculate the sum of all the elements between these two pointers. Okay, so I and j, I'm going to calculate sum between all of this, and then I'm going to update my global answer. Okay, this is going to store a maximum, and in the end, I'm going to return this answer. Okay, so let's visualize how this method is going to work. So as you can see, it's of n cube time complexity. I cannot draw all the approaches or all the iterations, but you can imagine after some iterations there will be a point where a starting point is going to be 4. Okay, so I is going to be 3, so 0 1 2 3, so starting point is going to be 4. Now j is also going to start from 3. Okay, so j is going to be so this subarray is going to have this single element 4. So current sum is 4. Maximum can be anything because we have skipped some iterations, but you can imagine there will be something which is less than the final answer. Okay. Same, we'll reach here and we'll have this 4 plus minus 1. This is going to give us current sum as current sum is 3. So again for the next iteration. So you can see as j is progressing from I to n, okay, from I to n, as j is progressing, we are increasing the size of the subarray for each of the starting point. Okay, so our correct answer one is this one where we have it of size 4, the current sum being same 6, maximum is also going to update to 6. Okay, for this iteration, and after this also there will be future iterations. Okay, so let's code this one. So first thing first, what we'll need is we'll need something that stores final answer. So it's going to be int min. I'm initializing it with int min so that it updates the answer even if it's negative. Okay. Next, we'll need a for loop. So for int I equals 0, I less than n, I plus plus. Next, we'll need another loop which is going to pick the end of a subarray. So for int j equals 0, sorry, j equals I, j less than n, j plus plus. Next, we'll need a sum. So int sum equals 0. Next, we'll need another loop which is going to traverse from I to j, and it's going to calculate the sum for us. So int k equals I, k less than equal to j, k plus plus, sum plus equals to nums of k. Okay, so this is calculating small subarrays, the sum of all the small subarrays, and since j is increasing, so the length of the subarray is also increasing. Okay, and after this we have to update our answer. So max value of answer comma sum. Okay, so this is going to be it, and in the end we have to return answer. Okay, so this is the brute force approach. Let's run this. Okay, so let's submit this. So you can see after 200 test cases, we hit a TLE, time limit exceed. That means we have to optimize the solution for a better time complexity. Okay, so let's see the second approach to solve this question. So now let's discuss the optimization part of this brute force approach to solve this question. Okay, so let's see what we can do here. So this is going to be an optimized approach where what we are going to do is, in previous approach, we used three nested for loops to calculate the answer. This time we are going to use two for loops and we'll have a running sum to calculate the net sum, and du- during that we are going to update our answer. Okay, so basically in this method what we have to do is, first we are going to initialize to pick the beginning, same as previous one. Second, we'll initialize a sum for the starting point. Then we'll start a second for loop, and then this second for loop is going to pick the end of the subarray, and slowly and gradually it's going to increase the endpoint of the subarray. And for each iteration we are going to add uh, update the sum which we initialized for this starting point, and we are going to update the answer too. Okay, and in the end we have to return the answer. So visualization of this method is also pretty much same, because we are not changing a lot from the previous method. The only optimization being, rather than using a net sum each time, we are using a running sum this time. Okay, so let's code this one. So what I'm going to do is I'm going to update this method only. Okay, so previously we used a brute force approach. Now I'm going to paste this, and rather than using this sum here, what we are going to do is we are going to remove this for loop part. Okay, we're going to remove this for loop part, and this sum is going to be initialized for this part, starting point. Okay, so for the starting point, this sum has been initialized, and this is going to be j. Okay, other than that there's no changes from the previous method. Same things, we are going to increase sum and update if it's greater than the previous value. Okay, let's run this. Okay, let's submit this. So you can see we got another TLE for O of n square time complexity also, where we passed 204 test cases. Last time we had 200 test case where we got TLE. So this method we passed extra 3 test cases, but it's majorly irrelevant because now we are going to study the most optimal approach to solve this question. Okay. Till now, we have solved this question using two methods, although very trivially in these methods. Now, we are going to use the third method, which is going to be optimal solution for this question, which is going to be Kadane's algorithm. Okay, so let's see what the Kadane's algorithm says. Basically, in this algorithm, what you have to do is, if we hit a sum where the current sum is less than 0, that means the whole subarray that is responsible for the sum less than 0 is irrelevant for calculating the largest sum of the subarray. Okay, so basically in this method what we're going to do is we're going to initialize a maxi that's going to store maximum, current is going to store current. Okay, and here you can see we are going to add nums of I to sum, and you are going to update maximum for the current max. Okay, so these are two straightforward methods from the previous two methods. Okay, this is the special part where if the current sum is less than 0, we are going to update the sum to 0. Okay, this means we are basically making all the elements that we currently calculated are irrelevant. Okay, this method is going to take a time complexity of O of n and space of O of 1. Why are we using Kadane's algorithm here? Okay, so you can see rather than adding the new element to make the net worse, so you can see the current sum is already less than 0. So adding a positive element is not going to give the maximum possible. Okay, hence rather than starting from that old initial point, we're going to start from a new sum where all the elements before the current elements were rejected for maximum sum calculation. Okay, So you can see the visualization for this one. First, we had this initialized part. Next, we'll start from I is equal to 0. So you can see starting, we have current sum as -2. Although we are going to update it, but you already know that the current sum will get back to 0 and will ignore -2 for all the subarrays. Okay. Next iteration will have 1. So it's going to update current and max both. Next, we'll have -3. So you can see we have ignored 2 and we have this as a small subarray. Okay. So current sum is -2, max is 1 because we had -3 and -3 and 1 being -2. So current sum is also less than 0. So we're going to ignore this whole subarray for the rest of the calculations. Okay. Next, we'll start from 4. So current sum being 4, max also 4. We had -1, current sum 3, but max is still 4. Next, we had 2, so current sum is 5, and max is also going to update to 5. And this is the answer one, where we reach 1 from I, and the current sum becomes 6, and max sum is also 6. Okay, so this is going to store a answer for us. Next, for next iteration, we had -5. So 6 and -5 is going to give us 1. It still is still greater than 0. Hence, we are still considering this as a starting point. Okay. Next, we had this 4. So current sum is 5 and max sum is 6. And in the end, you're going to return max sum. Okay. So this way, this whole algorithm works. Let's code this one. Okay. So I'm again going to copy from the above part. Okay. So you can see the whole algorithm, we are just pushing the sum to the outer loop. Okay. Again, we are going to push the sum to the outer loop where we initialize answer to store a final answer and sum to store the running sum. Okay. Again, I'm going to remove this for loop. Okay. And this. Okay. Okay. So you can see we have our two parts ready. Where first, this one is adding the new upcoming element, and the second is updating the maximum. And this is the condition. If sum is less than 0, sum equals 0. Okay. Since we don't have to return the index of the starting point or the ending point of which subarray we are actually returning, we don't have to worry about like what is the starting point of the subarray and the ending point. Hence, we can directly update sum is equal to 0 for this question specifically. Okay. So this is all for Kadane's algorithm. Let's run this. Okay. I still have J over here. It should be I, and I'll put this in braces. Okay. So it looks better. Okay. Okay. So let's run this. Okay. Let's submit this. So you can see we have solved this question using of n time complexity. Okay. So that's it for the video. Thank you.